Hello students, welcome to another video of number theory. Today we are going to start the third chapter of number theory. Chapter number 3 is quadratic reciprocity. Quadratic reciprocity. Quadratic reciprocity. So we know that the quadratic polynomial, the polynomial whose degree is 2 is called a quadratic polynomial. First of all, in this chapter we are going to see the definition of quadratic residue. Definition of quadratic residue. Quadratic residue. So the definition of quadratic residue is for all integers a, such that these a are, the integers a are relatively prime with m, such that GCD of a and m is equals to 1, then this a is called quadratic residue, then a is called quadratic residue under modulo m, quadratic residue modulo m if the congruence x square is congruent to a mod m, x square is congruent to a mod m has solution. If this congruence has solution, then we say that this a is quadratic residue under modulo m, since this a satisfies the congruence x square is congruent to a mod m. X square is congruent to a mod m has solution, and if there does not exist any integer that satisfies this congruence, that is, if there does not exist any a which is relatively prime to m and that number does not satisfy this congruence, then we say that this a which does not satisfy congruence is quadratic non-residue. If so, for all a which are relatively prime to m, then these a are called quadratic residues under modulo m if this congruence has solution. Now, if it has no solution, that is, if this congruence has no solution, if it has no solution, then a is called quadratic non-residue. Quadratic non-residue under modulo m. Quadratic non-residue under modulo m. So to check the residues, quadratic residues under modulo m, we are just going to find out the integers which are relatively prime to m, and putting one by one here. If we get the congruence is satisfied, then that number is quadratic residue, otherwise that number is quadratic non-residue. So it will be clear when we take the examples. So for example, suppose m is equals to 5, then we will find the quadratic residues and quadratic non-residues under modulo 5. To find the quadratic residues, we must find the numbers which are relatively prime to m. Here m is equals to 5. So there are 5 is prime number. So there are 4 possibilities, 1, 2, 3 and 4 are the integers which are relatively prime to 5, are the integers. Therefore, a is equals to 1, 2, 3, 4 are the integers which are relatively prime to 5. Relatively prime to 5. Now we are going to check one by one these integers satisfies this congruence or not. So to find quadratic residues and non-residues, to find quadratic residues and quadratic non-residues. We have to check the solution of the congruence. X square is congruent to a mod m. Here m is equals to 5, so x square is congruent to 1 mod 5. So for a is equals to 1, for a is equals to 1, x square is congruent to 1 mod 5. Now we are going to find the solution. This congruence has solution or not, and we know that to check the solutions of the congruence, we just check the CRS. So for suppose if we put the value of x is equals to 1, then 1 square is 1, and clearly 1 is congruent to 1 modulo 5, since 1 minus 1 is 0 and 5 divides 0. Here x is equals to 1 is solution. So this 1 is quadratic residue. There may be more than one solution for this congruence, since if you take x is equals to 2, then 2 square is 4, 4 minus 1 is 3, so 3 is not congruent to 5. Then x square, if you put the value of x is equals to 3, then 3 square is 9, 9 minus 1 is 8, and 5 doesn't divide it. If you put the value of x is equals to 4, then 4 square is 16, 16 minus 1 is 15, and 5 divides 15. So here there are two solutions, that is x is equals to 1 and x is equals to 4 are the solution of this congruence. So this a is equals to 1 is quadratic residue under modulo 5. Therefore a is equals to 1 is quadratic residue under modulo 5. So to find the quadratic residues or non-residues, we just put the values of integers which are relatively prime to that number m, and taking one by one and taking these congruences, x square is congruent to a mod m, and finding the values of x. If there is no x exist such that x satisfies this congruence, then we will say this number a is quadratic non-residue. So for a is equals to 1, now we will check for a is equals to 2. So if a is equals to 2, or for a is equals to 2, then x square is congruent to 2 modulo 5. Now to check the congruence solution of this congruence, we put the value of x is equals to 1. So 1 square is 1. So 1 minus 2 is minus 1, and 5 doesn't divides minus 1. So x is equals to 1 is not solution of this congruence. So we cannot say that this 2 is quadratic non-residue, since x is equals to 1 is not solution. So we will check for x is equals to 2, 3, 4, all numbers which forms CRS under modulo 5. So if we put the x is equals to 2, then we will get 2 square is 4, 4 minus 2 is 2, again 5 doesn't divides 2. X is equals to 3, then 3 square is 9. 9 minus 2 is 7, 5 doesn't divide 7. So x is equals to 3 is again not solution. If you put the value of x is equals to 4, then we get 4 square is 16 minus 2 is 14. Again 5 doesn't divide 14. So all the integers which forms the quadratic residue under modulo 5 are not satisfying these congruences. Therefore x square, this congruence has no solution. Therefore this congruence has no solution, since to find the solution of any congruence, we just check for every element of CRS under modulo m. Here 1, 2, 3, 4 are the elements in the CRS. So checking for all these 4 numbers, we cannot get the solution of this congruence. So therefore we can say that this congruence has no solution, and this congruence has no solution means a is equals to 2 is quadratic non-residue, is quadratic non-residue under modulo 5. Quadratic non-residue under modulo 5. After getting this congruence, we have to check for all the integers which forms the CRS under modulo m. Here there are 4 integers 1, 2, 3 and 4. So checking for all those 4 integers, we cannot get the solution from that. So we can say this is a is equal to 2 is quadratic non-residue. So you have to check for each and every integer which satisfies which forms CRS under modulo m. Now for a is equals to 3 and a is equals to 4, we are again going to check. For a is equals to suppose 3, x square is congruent to 3 modulo 5. Now again we are going to start from 1. 1 square is 1, 1 minus 3 is minus 2, and 5 doesn't divides minus 2. So 1 is not solution of this congruence. Now for x is equals to 2, 2 square is 4, 4 minus 3 is 1, 5 doesn't divides 1. X is equals to 3, 3 square is 9, 9 minus 3 is 6, 5 doesn't divide 6. X is equals to 4, for x is equals to 4, 4 square is 16, 16 minus 3 is 13, 5 doesn't divide 13. So this congruence has no solution. This congruence has no solution. So we can say that a is equals to 3 is quadratic non-residue under modulo 5. You have to write all this word quadratic non-residue. Now for the last element, for a is equals to 4, we get the congruence x is congruent to, x square is congruent to 4 modulo 5. If you put the value of x is equals to 1, then we get 1, that is 1 square is 1, and 1 minus 4 is minus 3, and 5 doesn't divide minus 3. Similarly for x is equals to 2, we get 2 square is 4, and 4 minus 4 is 0, 5 divides 4. So we get x is equals to 2 is solution. And for the next integers, if we check for x is equals to 3, then we get 3 square is 9, 9 minus 4, 9 minus 4 is 5, and 5 divides 5. So 3 is again solution. For x is equals to 4, 4 square is 16 minus 4 is 12, and 5 doesn't divide 12. So we get x is equals to 2 and 3 are the solutions of above congruence, or the solutions of x square is congruent to 4 modulo 5. Hence a is equals to 4 is quadratic residue. Hence therefore a is equals to 4 is quadratic residue modulo 5. Residue modulo 5. Hence we get a is equals to 1 is quadratic residue, and a is equals to 4 is quadratic residue. So hence we get a is equals to 1 and 4 are quadratic residues, and a is equals to 2 and 3 are quadratic non-residues, under modulo 5. So to find the quadratic residues, we just check the solutions. From this example, it is more clear that the definition of quadratic residue is, if residue of a and m is equals to 1, then a is said to be quadratic residue if the congruence x square is congruent to a mod m has solution, and if this congruence has no solution for each and every a which is relatively prime to 1, then we say that number, which suppose here we have a is equals to 2, and for a is equals to 2, this congruence has no solution. So that number is quadratic non-residue. Numbers a which are relatively prime to m, and this congruence x square is congruent to a mod m has solution, so that number is quadratic residue, otherwise that is quadratic non-residue. From this example, we have seen that for m is equals to 5, numbers which are relatively prime to 5 are 1, 2, 3, 4, and checking for each number 1, 2, 3, 4. For a is equals to 1, we get the congruence x square is congruent to 1 mod 5, x square is congruent to 1 mod 5. So after that, checking for each number in the CRS under modulo 5, we know that to find the solution of any congruence, we just check for the numbers which forms CRS under modulo that m. Here m is equals to 5, so CRS under modulo 5 is 1, 2, 3, 4. For putting x is equals to 1, x is equals to 2, x is equals to 3, and x is equals to 4, we get 4 different congruences from which only x is equals to 1 and 4 satisfies this congruence. So we say that 1 and 4 are the solutions of this congruence. So we get this congruence has solution x is equals to 1 and x is equals to 4. This congruence has solution means this number is quadratic residue under modulo 5. So similarly for x a is equals to 2, 3 and 4 we have checked, and from that we get a is equals to 1 and 4 are quadratic residues and 2 and 4 are quadratic non-residues. Similarly, the next example is find or check whether m is equals to 8 has, or find all the quadratic residues under modulo 8. This is for your homework. Just check for the numbers which are relatively prime to 8. Here the numbers which are relatively prime to 8 are 1, 3, then 5 and 7. So checking for each number and finding the solutions and which forms the CRS under modulo 8, you will get the quadratic residues and quadratic non-residues. Next definition is, and the important definition of this chapter, Legendre symbol. Legendre symbol. Legendre symbol. So Legendre symbol is defined as if P denotes a odd prime, if P denotes an odd prime, if P is an odd prime, then the Legendre symbol, then the Legendre symbol, then the Legendre symbol which is denoted by Legendre symbol denoted by Legendre symbol of A and P in the round bracket, write A and after that P. Legendre symbol of A and P is denoted by this and is defined to be 1, minus 1 and 0. Is defined to be 1 if this A is quadratic residue. A is quadratic residue under modulo P, quadratic residue modulo P, comma is defined to be minus 1 if A is quadratic non-residue, quadratic non-residue, quadratic non-residue under modulo P, under modulo P, and is again defined to be 0 if P divides A, if P divides A. So Legendre symbol is defined to be 1, minus 1 or 0 and depend on whether that congruence x square is congruent to A mod P has solution or not, or defined on if this A is quadratic residue, non-residue, or this P divides A. So Legendre symbol of A and P is denoted by in this manner, that is in the round bracket A and then P. Legendre symbol of A by P, Legendre symbol of A and P, it is not A by P. Legendre symbol of A and P is denoted by this and defined as the value of Legendre symbol of A and P is either 1 or minus 1 or 0 and depend on whether this A is quadratic residue, quadratic non-residue, or this P divides A. So we can write this definition as, that is Legendre, just to make one correction in this symbol, Legendre symbol of A and P, I think this notation is A by P, that is Legendre symbol of A and P is defined to be 1 if A is quadratic residue, under modulo P. It is defined to be minus 1 if A is quadratic non-residue, quadratic non-residue under modulo p, and is defined to be 0 if p divides a. If p divides a, this Legendre symbol of a and p is defined to be 1. It is not congruent, it is defined. It is equals to Legendre symbol of a and p is equals to 1 if a is quadratic residue under modulo p, or we can say that a is quadratic residue under modulo p means x square is congruent to a mod p has solution. We can say that Legendre symbol of a and p is equals to 1 if this a is quadratic residue and a is quadratic residue when this congruence has solution, and it is defined to be minus 1 if a is quadratic non-residue, that is if this congruence has no solution. X is congruent to a mod p has no solution. So this is the definition, that is of Legendre symbol. Legendre symbol of a and p is either 1, minus 1 or 0 depending on whether a is quadratic residue, quadratic non-residue, and p divides a. If p divides a, then we are going to just write Legendre symbol of a and p is equals to 0. If this p doesn't divide a, then we will check either this congruence has solution or not. If this congruence has solution, x square is congruent to a mod p has solution, then we will say that residue of a and p is equals to 1, and if that congruence has no solution, then we will say that the Legendre symbol of a and p is equals to minus 1. This is the definition of Legendre symbol. So for example, or we can take the example, find the Legendre symbol of 2 and 5. Legendre symbol of 2 and 5. To find the Legendre symbol of 2 and 5, we know that the values of Legendre symbol are 1, minus 1 or 0, except that you will not get the value of Legendre symbol as 3, 4, 5, just 3 values are there, 1, minus 1 and 0. Your value of answer of this example must be either 1 or minus 1 or 0 depending on whether the congruence x square is congruent to 2 mod 5 has solution or not. Here a is equals to 2 and p is equals to 5, then residue of a and p, which is equals to residue of 2 and 5, is clearly 1, and this congruence x square is congruent to a mod p. The residue of these two is 1 means this p doesn't divides a, so there should be solution is either 1 or minus 1. So here x square is congruent to a mod p, which is that is the congruence x square is congruent to 2 mod 5. X square is congruent to 2 mod 5 has solution or not. We have seen in this example that x square is congruent to 2 mod 5 has no solution. So we can say that this is quadratic non-residue. A is equals to 2 is quadratic non-residue. Therefore, this Legendre symbol of a and p, that is 2 and 5, is equals to minus 1. Here x square is congruent to 2 mod 5, and this congruence x square is congruent to 2 mod 5 has no solution. Therefore, Legendre symbol of 2 and 5 is equals to minus 1, since the definition says that this congruence has no solution, then Legendre symbol of a and p is equals to minus 1. So here this congruence has no solution, so Legendre symbol of 2 and 5 is minus 1. So similarly, we are going to find the Legendre symbol of in the next example. Next example is find the Legendre symbol of 4 and 5. Question is of the form find just Legendre symbol of 4 and 5. So here a is equals to 4 and p is equals to 5. So here 5 doesn't divide 4. So from this we are clear that our Legendre symbol is either 1 or minus 1, and so to find this Legendre symbol is 1 or minus 1, we will going to check the congruence x square is congruent to 4 mod 5 has solution or not, and we know that x is equals to 4 is solution of this congruence, and this x is equals to 2 square 4 minus 4 is 0. So 5 divided 0, x is equals to 2 is solution of x square is congruent to 4 mod 5. So, this congruence as solution means x is equal a is equals to 4 is quadratic residue, therefore, Legendre symbol of 4 and 5 is equals to plus 1, hence the solution. To find the Legendre symbol of such numbers, so before that take one more example. Find the Legendre symbol of suppose 15 and 5, Legendre symbol of 15 and 5. Here a is equals to 15 and p is equals to 5, and from this we can say that this p, that is which is equals to 5, divides 15, 5 divides 15. So, Legendre symbol of a and p, which is equals to Legendre symbol of 15 and 5 is 0. To find Legendre symbol of any two numbers, we are just going to check whether our prime p divides that a or not. If prime p divides the number, then we are done, that is our solution is 0. If that prime doesn't divides a, then we are going to check that congruence x square is congruent to a mod p as solution or not. To find the solutions of such problems, we have some properties. After using that property for the larger number, suppose for if we have given the 13 and 5 or some larger numbers, to check or to find the Legendre symbol of such numbers, we will use the properties that we are going to discuss in our next lecture.